Section 5.4 will have an assignment with it, okay? And so the title of this one basically I think is just properties of logarithms. And now there's really only 3 properties of logarithms to be aware of. There are 3 major ones. There's a couple other minor ones. I'll try to mention all of them here. But hopefully you watched the previous video on logarithms. So the first thing we say is we're going to let m and n just be positive numbers, or more commonly they're algebraic expressions. Usually they're just x and y, stuff with x and y, or any letters, okay? So the product rule goes something like this. Log base a of mn equals log base a of m plus log base a of n. All right, now that's for any base. It could work for the common log. I could write this again with just the common log. Notice the base is not, the little a is not there anymore. Okay, there's no number down there. Or it will work for the natural log. But the thing to remember is with the product rule starts with a log expression that has, in this case, m times n. You have to notice that there is a product. mn is an expression for a product, m times n. And we're going to change that into this expression, okay? Remember, this one has a plus. So we're going to break it apart, basically, okay? With this rule, you can break it apart into what I call expanded form, okay? All right, now, the next thing to make a note of here is that these rules don't have to stop with m and n. It could work for 3 letters, or 4, or 5, or 6. The basic rule still applies. You're going to have log base m plus log of n plus log of p, okay? And it can go on forever. You just need to recognize that the log has a product in it, okay? And we break it apart with a plus sign, okay, when we expand it. Next one is a quotient rule. Quotient rule goes like this. Log base a of m over n equals log base a of m minus log base a of n. And again, I could rewrite this with the other logs. The common log of m over n is equal to the log of m minus the log of n, or I could do the natural log. It's the same rule, it's just a different logarithm at the beginning. So again, the thing to notice here, I think, is that you start with a fraction. Fraction is a quotient, is division. Fraction represents division. So when you have this fraction, you break this one apart with a minus. You notice all these had a minus, whereas the previous one had a plus. Okay. Now each of these properties by themselves isn't that difficult, but it's when the problems start to have 2 or 3 rules in one problem that'll be more challenging. Okay. So the obvious thing for this, I think, is that you start with a log expression that has a fraction in it. Okay. That's a quotient. You break it apart and you write your 2 log expressions separated by a minus symbol. Okay. The third one, and then I'll get to the minor ones after this. The third one is called the power rule. Now this one is used a lot. It's used in almost every problem I assigned. It's used on almost every problem in section 5.6. Okay, so the power rule of these 3, quite honestly, the power rule is probably the more important one. This one goes like this. Log of m to the r is equal to r log of m. And again, I could write this with other bases. It doesn't have to be base a, but it can. It works for the natural log. And remember, m can be anything, basically, any algebraic expression. So the exponent, the thing that you got to notice on all three of these things that I just wrote is that the exponent ends up coming out front. Okay, so when you have a log expression that has a power up here where this r is, this power ends up dropping down in front of your logarithm. You notice it comes down front in all of these. Okay, that's called the power rule. And again, it's a simple one, but it's probably the most important one from this section. Okay, and the last little minor ones I didn't even type up here, but I'll remind you. Log base a of 1 is always equal to 0. Okay, log base a of a is always equal to 1. If you can remember that one, that's going to save you a little time when you go through the homework. This one actually, the most common thing that shows up is ln of e. Well, remember the base of ln is an e, so the ln of e is actually equal to 1. Okay, and again, I'm just trying to give you a warning. That one comes up a lot. ln of e is equal to 1. And the last couple little reminders deal with exponents. We actually did this on the first night of class. X to the 1/3 is the same as writing the cube root of x, and x to the 1/2 is the same thing as writing the square root of x. With logarithms, we don't have rules that deal with radicals. So with logarithms, when you're given a problem that has radicals in it, you're going to want to switch those radicals into exponents. So for example, if I give you log base 3 of the square root of x, and I asked you to rewrite that, expand it, using one of those properties on top. We're going to use the power rule, actually. But you have to remember, if this is the original problem, you have to remember that this is equal to log base 3 of x to the 1/2. Then you can expand it. You can bring this 1/2 down front. So 1/2 log base 3 of x would be the expanded form, basically.